Video 2. Introduction to the XPages Request Processing Lifecycle. My name is Tony McGuckin. I'm a senior software engineer with IBM in Ireland. I'm an XPages runtime subject matter expert and work on research and development of the server, client and mobile runtime, customer enablement, proof of concept development and technical pre-sales. I'm also involved with areas of user experience, performance and scalability, and system architecture. I'm a co-creator of the Global XPages workshops, an OpenNTF contributor, and sit on the IBM One UI Web and Mobile Adoption Workgroup. Further to this, I have co-authored 2 publications on XPages, the Mastering XPages book and the XPages Portable Command Guide book. Currently, you are watching Video 2. Video 2 is an introduction to the XPages Request Processing Lifecycle. In this second video, you will learn about XPages and the Javaserver Faces framework. You will also gain an understanding of an XPages request. In the first of 2 topics covered in this video, let's look at XPages and the Javaserver Faces framework. Javaserver Faces is a component-based development model and framework. It provides a stateful runtime for server-side user interfaces or server-side Java applications. It provides a server-side expression language, scripting and binding model, and provides a framework which can be extended to adapt to custom requirements. It is also part of the J2EE specification or the J2EE stack from Oracle. The Javaserver Faces framework can be used to simplify construction of complex Java server-side user interfaces. Developers of various skill levels can quickly bring together powerful web applications by assembling reusable user interface components into a web page. Developers can then connect these components to an application data source and then wire together client-generated events to server-side event handlers or actions. So this is where the relationship between XPages and Javaserver Faces, or JSF, begins. XPages as a runtime platform extends the JSF reference implementation. It does so in several important ways. For example, XPages provides a specialized set of controls and data sources specifically catered for Notes Domino application development. XPages also provides a highly optimized component view event model. This model is tightly integrated with client-side and server-side JavaScript and other scripting models. These scripting models are also tightly integrated with a highly specialized partial refresh and partial execution model. XPages also provides its own specialized server-side expression language, server-side JavaScript, and XPath scripting binding model. These are all specially adapted for Notes Domino application development. For example, there is tight integration with the Domino object model. XPages also provides a very powerful client-side JavaScript scripting model. This is accessible using the XSP client JavaScript object. This object is a decorator for the industry standard, highly proven Dojo library. XPages also has its own specialized stateful runtime or persistence layer that enables highly optimized application behavior. XPages provides numerous extensions and new capabilities over those provided by JSF. To call out a few that are related to the performance and scalability area, I've chosen a few here from a very long list. First off, as already stated, there are many optimizations and extensions against the request processing lifecycle itself. XPages also introduces its own dynamic component tree API to assist with the creation and destruction of component trees on the server side. JSF provides the rendered property, but XPages goes further in that it introduces a new loaded property. The rendered property itself has been optimized by XPages to avoid or reduce multiple execution of this property within the render response phase. XPages also introduces a new disable validators property for event handlers. Partial execution has also been introduced, allowing control of execution for a request issued by an event handler. View level events have also been introduced. These allow you to specify events that trigger at key stages of the request processing lifecycle. For example, before page load, after page load, and so forth. The event handler object has also been introduced by XPages, complete with a new set of simple actions. This is highly integrated with the partial refresh and partial execution programming model. XPages also provides its own highly configurable state management persistence layer that includes options for in-memory, on-disk, or indeed both, along with options for setting the number of persistent views and so forth. This list is by no means extensive. There are many more extensions and new capabilities that go far beyond what we see here. However, over and above all of the features and capabilities that we see with XPages and from Javaserver faces, as an XPages developer, it is imperative to understand the core principles of this framework. This is important in order to gain maximum application performance and scalability from your XPages server-side application. It is also important in order to ensure consistent application data integrity. Firstly, the framework provides a stateful web application framework. Every request and response goes through a process of saving and restoring state. This means effectively that your Domino server is a state machine. It introduces the notion of a parallel universe between client, browser, and server. Every request and response must ensure that the state that is held within the state machine, aka your Domino server, is kept synchronized between client, browser, and server. Secondly, the framework provides a component-based architecture. This means that for every XSP tag you have in an XPage, there is a server-side object representation at runtime. Effectively, at runtime, this means that for any given XPage, there is a hierarchy of components held in a component tree and saved within the state machine. Thirdly, the framework provides mechanisms to ensure conversion and validation are handled consistently. Data integrity is paramount at all times. And finally, the framework provides an overarching mechanism that governs requests using a 6-phase lifecycle. This 6-phase lifecycle is extended by XPages. And as an XPages developer, as you develop your XPages, you should ensure that for every request, server-side memory and CPU usage is kept to a minimum. In this second section of video 2, let's now gain an understanding of an XPages request. There are lots of factors to consider that will ultimately determine the performance and scalability of any given XPages application. For example, the requesting user agent, should that be a browser, the XPages Notes client, or some mobile device, has its own work to do in order to process any given request or response, such as resource caching, size of request or response, that is the physical size, the number of requests and responses, parsing of JavaScript and CSS files, actually calculating the layout of the page, and then painting or rendering the final page. All of these user agent related processes, when accounted for together, will certainly make up a portion of time for any given request or response. Secondly, a distributed system architecture will present its own unique challenges. Things to consider include data replication and indexing, conflict resolution, remote versus local execution of application logic, node availability and failover, and design propagation. Thirdly, there is also the network to consider. A network experiences its own stress and load issues, both with hardware and software. There is bandwidth, latency, and contention issues, which will also account for a portion of time for any given request or response. Finally, there is the underlying server or client hardware. The hardware has two main critical parts that will determine how an application behaves. There is the central processing unit, or the CPU, but also memory. And that memory can be either physical or virtual. So this is the focus area of this first video series. Understanding the XPages Request Processing Lifecycle is critical to effectively minimizing CPU and memory usage within the server or client hardware. All of the other factor areas, such as the requesting user agent, the distributed architecture, or the network, all have specific features and capabilities within XPages to overcome limitations within these areas. So let's now take a look at an XPages request. Let me try to explain to you how an XPages request is processed against the XPages Request Processing Lifecycle. In the following description, I'm going to show you some high-level XPages architecture. It doesn't account for everything that happens for a request, but it highlights some of the specific areas that deal with the Javaserver faces framework, and the XPages request process. So basically there are two scenarios. In scenario 1, a request is issued against a Domino server or the HTTP process. In scenario 2, an XPages request can be issued inside the XPages Notes client. In either case, the request is delegated into the OSGI framework. The OSGI framework then loads the XPages runtime if it is not already loaded. The XPages runtime itself is tightly bound with the Notes Domino backend through JNI interfaces. In that backend, we have the C and C++ services, but also the database layers. So there is direct exchange between the XPages runtime and the backend. Next, the XPages runtime loads the Javaserver Faces framework if it's not already loaded, and begins to invoke the XPages Request Processing Lifecycle process. Subsequently, any other XPages extensions, such as the XPages extension library or any other OSGI-related bundles, are loaded. Concurrently, the XPages runtime is loading the required NSF application or component module, or indeed several of them if required by the incoming request. Subsequently, the XPages runtime is also invoking the state management layer. During this process, a .class file is extracted from the appropriate NSF component module based on the incoming target URL. That .class file will be used during the process of either creating or restoring the appropriate component tree for the associated XPage. All of this processing is happening under the direction of the XPages Request Processing Lifecycle. And ultimately, all of the processing drives back towards creating a response. That response is then sent back to the requesting server or XPages Notes client. The key point to understand is that central to all of this processing for any given request or response is the XPages Request Processing Lifecycle. This process sits at the core of any given request or response and ultimately governs how any request is processed in order to send back a response. And most importantly, as an XPages developer, you must be aware of the fact that this has a direct relationship with CPU and memory usage whilst processing any given XPages request. And as you will come to learn as we study the XPages Request Processing Lifecycle, you as the XPages developer have the most influence over the degree of processing that occurs within the XPages Request Processing Lifecycle. I will now describe some of the key aspects of the XPages Request Processing Lifecycle. Firstly, for XPages requests, it is typically executed for HTTP GET and POST requests. Other HTTP type requests can also be catered for, such as put, delete, and so forth. In the case of a GET request, phases 1 and or 6 will normally be executed. That is the restore view phase and the render response phase that we see in the flowchart. For a POST request, phases 1 through 6 with some variation in terms of the phases that are executed. That is the restore view phase, apply request values phase, process validations, update model values, invoke application, and render response phases that we see in the flowchart will normally be executed. In terms of the actual phases, they are categorized as follows. There are two system level phases, the restore view phase and the render response phase, phases 1 and 6. These are executed for most HTTP GET and POST requests, where there is a subtle difference between a normal HTTP GET versus a HTTP AJAX GET request. There is also 4 application level phases, phases 2, 3, 4, and 5. The apply request values phase, process validations, update model values, and invoke application that we see in the flowchart. These are executed for HTTP POST requests with some variance depending on the requirements of the request. You will also note the presence of 4 process events phases within the flowchart. These are event pseudo phases. These event pseudo phases are executed just after each of the application level phases in order to check the outcome of the previous phase execution. This outcome is then used to determine whether to proceed to the next phase in the life cycle or to back out of the lifecycle altogether, or indeed fail over and go to the render response phase. Typically, the process events phases are used to check on conversion or validation, or data model state, or business logic outcomes. Let's now take a look at some of the semantics that are involved with making an XPages request. So here in my browser, what I'm going to do is put in the URL of an application on my server and hit the enter key. So off it goes and retrieves the target web page, in this case the members.xsp page. So in terms of what has happened for that simple use case, we typed in a URL into the browser URL bar. That caused a standard GET request to be issued against the XPages runtime. So given that it was a standard GET request, not an AJAX GET request, the request has come into the Domino server. It has been delegated into the XPages runtime, and the XPages Request Processing Lifecycle then kicks in. Phases 1 and or 6 are involved in this particular use case. That is the restore view phase and the render response phase. So given that it is a standard GET request, there will be no corresponding component tree already existing on the server side. So in terms of restore view phase, it will be skipped in this case. The XPages runtime verifies that there is no pre-existing component tree, hence skips directly to the render response phase. During this phase, the XPages runtime will create a new component tree that corresponds with the associated XPage and persists that into the state management layer. The XPages runtime then executes the render response phase and asks each of the components within that component tree to render their corresponding HTML markup. Therefore, we get the response coming back to the requesting client browser. So let's now come back to our help desk application and try something slightly different. Notice here that I'm still sitting on the members.xsp page, but what I'm going to do is click on Add Member. And immediately I'm presented with a form allowing me to effectively add a new member. But yet again, I am still sitting on the members.xsp page, as you can see here by the URL. So effectively here, what I'm doing is interacting with the persisted component tree that represents the members.xsp page. One important thing to note about this form is that both the name and email field are required fields. This means that both these fields have a required validator, essentially. More than that, the name field also has a second validator, which checks if the selected name is already a member of the help desk. In addition, it is important to also note the fact that the email field is using client-side validation versus the name field, which is using server-side validation. So before filling out this form and trying to save it, I'm going to open up my developer tools, simply because I want to understand what requests are made as I interact with this form. So having opened up the developer tools, instead of filling in any of the required fields or any of the other fields, let's just simply go ahead and click on Save. So first off, what we can see is that the client-side validator for the email address is invoked immediately, and no request has been made from the browser to the Domino server. I know this because I can see clearly inside the network traffic, inside my developer tools, that nothing has been issued. And of course, the dialog that we see here tells us that we're missing the provided field for the email address. Now let me just click on OK to get rid of the dialog. And in this case, let's go ahead and supply some email address. And now let's try the same thing again. Let's click on Save. So in this instance, we've actually made a request, as we can see here in the network traffic. This has happened because we have gotten past the client-side validator for the email field, which has then allowed the request to be issued against the Domino server. But in this case, one of the two
server-side validators on the name field has been invoked, in this case the required validator, telling us to please select a member name. So let's now go and select a name for the new member. Click OK here. And also let me clear the console information. And again, come back and let's proceed to submit. So again, we have successfully submitted to the server side. And again, here I can see the post request has been issued. But once again, we have not successfully saved the form because the second server-side validator on the name field recognized that Samantha is already a member. So let me just close the developer tool and let's choose a different name. Let's say we go for Sam Brooks this time. Click OK here. And now I click on Save. So now we have successfully added Sam Brooks into the help desk. So before going back to the lifecycle flowchart for an explanation of what we've just done, let me show you something slightly different. Here again, what I'm going to do is choose to add a member. And we already know that we have two required fields, that's the name and the email field. And of course, the name field has a secondary validator checking if a name already exists. But the other thing that we did notice was the fact that we had the email field using client-side validation versus the server-side validation used for the name field. So let's say for all intents and purposes that I want to compromise the system. I'm a hacker, I'm a bad user, and I want to get past the client-side validation. So let's just do a little bit of ethical hacking in order to suppress the client-side validation on the email field, and we'll go ahead and try and save the form. So once more, what I'm going to do here is open up the developer tools. And just to explain to you what I'm doing, I'm typing in some client-side JavaScript, which is allowing me to effectively compromise the client-side validator. And now I'm going to close the developer tools, given that I have now suppressed the client-side validation in this case. And let's go ahead and select a name. In this case, let's go ahead and add Gail Chow. Click OK. And as explained, we have simply removed the client-side validator from the email field, and we're going to try and save the form. So I go ahead and click on Save. And what is very interesting, but also comforting to note, is the fact that the client-side validator, even though I have compromised the system and being able to hack my way past the client-side validator, the server side still honors the validation rule. So this is one very good case where we can see the parallel universe at play. We've got our state machine, aka our domino server, still being able to honor the design rules, the validation and the conversion and so forth, the rules of the application. And that state machine still provides data integrity at all times, as we can see here. So like I said before, everything that you see in your browser or your mobile device or your XPages Notes client in terms of a user interface, there is a corresponding in-memory componentry representation of that in the state machine on the domino server at all times, and the two must be kept in sync. So for each of the examples that we've just looked at, centered around adding a new member inside the help desk application, we are dealing with HTTP post type requests whenever we click on the save button. So I'll try to explain the semantics behind those requests. Firstly, let's think of the very first example we looked at. We had the two required fields, but we left both intentionally blank. We then seen the client-side validation being invoked for the email field, and of course there was no request made. In that case, that makes perfect sense. because the client-side validator stopped any subsequent request being made by the browser itself. So that implies a couple of things about client-side validation. In a general sense, client-side validation can be very effective as both a user experience improvement, but also for performance reasons. If you can think of it in terms of performance reasons, well, it's simply because you're not posting requests back to the server unnecessarily. And in terms of the user experience, the end user is getting an immediate response. Now, the caveat in that case is the fact that, as we've seen in the very last example with Gail Chow, the system can be compromised. With doing a little bit of ethical hacking, I was able to suppress the client-side validation and still then be able to submit back to the server. But because of the semantics behind the XPages runtime itself and the idea of the state machine with a component tree and this notion of the XPages Request Processing Lifecycle, my compromised request was still governed by the rules of the design of the application and by the lifecycle itself. So let's take a deeper look at our second example, whereby I had supplied an email address but intentionally left the name field blank. So essentially, when I clicked on the Save button, we submitted the request into the XPages runtime. The runtime restored the previous component tree from the state management layer. Remember back from our examination of the GET type request, we had looked at just simply typing in the browser URL and hitting the enter key, and the runtime then effectively just skipped into the render response phase and created the component tree and persisted that into the state management layer. Well, effectively we were looking at the members.xsp page. In this case, we're also dealing with the members.xsp page. We're in the same session, so essentially what we're doing here is posting back our add member form against the exact same XPage. So this allows the XPages runtime inside the restore view phase to recognize the fact that yes, there is a pre-existing component tree representing the members.xsp page, and proceed then to move into the apply request values phase. In the apply request values phase, what the XPages runtime is doing is extracting the incoming values for each of the edit boxes that we've seen inside the add member form. Extracting those values and trying to apply them against the in-memory components that represent those edit boxes within the component tree. So essentially, it's taking the submitted value from each of the edit boxes, and each edit box has its own instance of its component within the component tree. That submitted value is then used to apply against the component's temporary value, its submitted value. So that process completes, and then the runtime proceeds into the next phase of the lifecycle, the process validations phase. In this phase, this is where validators and converters and any other type of validation code will be processed. So in this case, we do know that we have the validators on the email and the name field. And in the case of the name field, there are indeed two validators. One that checks if there is a value, and secondly, if that name already exists within the help desk application. So in this instance, given that we have not supplied a value for the name field, the field is blank. Hence, the required validator fails in this case. So during the process events pseudo phase, the required validator that has just failed on the name field has queued an error message for subsequent use, and therefore the process events pseudo phase stops any further application phase execution and instead fails over directly into the render response phase. In doing so, inside the render response phase, that queue of error messages is then used to notify the end user of the offending validation failure. Hence, we see the inline error message appropriate to that name field, and so forth. So in the render response phase then, each of the components are asked to render their corresponding HTML markup. And of course, the error message is also included in that response output. Now let's take our next example, whereby we did supply a value for both the email field and the name field. But in this case, we supplied the name of Samantha Darn. But of course, Samantha is already a member of the help desk application, as we subsequently found out. But nonetheless, let's study the semantics of the request. So the request came into the restore view phase, the component tree was restored, apply request values extracted the incoming submitted values, including the name of Samantha Darn, and subsequently moved into the process validations phase. In this case, the required validators did not fail because both fields had their corresponding values. But of course, the second validator on the name field is now checking if the name Samantha Darn already exists within the members of the help desk. And of course it does. Hence, another validation failure is logged and the error message is queued for subsequent use. And again, inside process events, pseudo phase, no further application phases are allowed to execute. And we then have the exact same failover into the render response phase as we seen in the previous example. And again, each of the components render their corresponding HTML markup, including the inline error message control, allowing the end user to see the offending validation failure. So now let's come back and study our second last example, whereby we supplied the value of Sam Brooks as the new member, and we had also given Sam Brooks an email address. So in this case, again, the request comes in, restore view, the corresponding component tree is restored, the submitted values are applied against each of the edit box components, and the runtime proceeds to the process validations phase. And in this instance, each of the validators succeeds and there is no failures. So the XPages runtime is allowed to proceed to the next application level phase. So in this case, we're dealing with the update model values phase. In this phase, the XPages runtime is now able to trust the submitted value and also apply that against the components and any of the bindings that are on the components. So for example, the name of Sam Brooks in the name field is now applied against the component's own local value, but also set upon the domino document binding on that particular name input field as well. So when the update model values phase has completed, the XPages runtime is then allowed to proceed to the invoke application phase. So the invoke application phase is about invoking event handlers and any custom business logic that may be associated with the incoming request. So within the invoke application phase, in our particular case, we have the save button. That save button has a save document simple action. So the save document simple action is now asked to invoke itself. It then carries out the task of actually resolving the domino document and saving that into the backend domino data source. When the save action successfully completes, the runtime is then allowed to proceed to the render response phase, and the same process occurs as described previously. Each of the components are asked to render their corresponding HTML markup, and of course the end user then sees the response. You have now been introduced to the XPages Request Processing Lifecycle. In particular, you have seen how it deals with two types of HTTP request, namely the GET and the POST type HTTP requests. And as described earlier, the XPages Request Processing Lifecycle sits at the core of any given request or response. And it is you as the XPages developer that will have the most influence over the amount of processing that occurs. And as we move into videos 3 and 4 of this first series, you will then learn about how you can affect that influence and then fully optimize your applications to make maximum use of the XPages Request Processing Lifecycle to minimize the amount of CPU and memory usage for your XPages requests. In summary, you will now understand that the XPages Request Processing Lifecycle underpins any given XPages request and response to a Domino server. It also contains 6 phases. Phases 1 and 6 are known as system-level phases. These are typically nearly always invoked with a slight difference between a GET and a AJAX GET type request. Phases 2, 3, 4, and 5 are known as application-level phases. These phases can be leveraged by application developers for different use cases. By understanding how to properly leverage these phases, an application can be more efficient when processing a request executed through the XPages Request Processing Lifecycle. Ultimately, an XPages request can be skipped through one or more of the application level phases under certain circumstances. This will reduce CPU processing and better utilize memory on the server, therefore increasing performance and scalability of your XPages applications. Thank you. This is the end of video 2 from the first series.